Hi everyone. Hi everyone. Can you guys hear me?
Yes, Professor.
Okay. So I just posted all the quiz 3, 4, and solution for homework 1. I even post quiz 2 already have the solution, quiz 1 and 5, because I don't know what happened to the Canvas quiz. I don't see the submission for quiz 1 and 5, so I just posted again. And then because you are like unhappy about quiz 5 ago, we didn't notice what was the first question, so I posted it. Does it make sense?
It was posted again, but we weren't able to retake it if that was the intention.
But I think now it's posted, am I right?
Yeah, no, it's posted, but because we've taken the quiz already, it won't let us take it again. So it shows our old submission.
Oh, okay, that's fine. If that's the case, it's fine. So I will grade them. So the purpose was to do it, but it's okay. We need to focus on midterm actually, so that's fine.
I thought the quiz was gonna be open till midnight, so I missed the deadline.
So what do you mean? They say they already submitted, they use the previous submission. Probably you don't need to submit anything. Am I right?
Yeah, but I missed the first quiz. It's okay.
The first quiz, why? If you took the first quiz already, so you don't need to submit it again.
Yeah, I missed the first quiz.
When?
The first day? I don't know.
I think that's passed. So the reason I post the quiz for the people to just take it. So if you pass the first quiz, that's fine. You just passed it. So probably that's fine.
I have a
So-
quick question.
Go ahead, please.
For quiz 3, there were a few of us while we were in Zoom that we said that we had a little trouble submitting. So you said it was okay just for that quiz to email.
I know. I saw your email. I am so sorry I didn't have a chance to grade them. I saw some of you guys send my email. I didn't have a chance, you know. I will grade them.
Okay.
Just wanted to make sure.
Yeah, also,
Yeah.
is this also regarding to like other quizzes for like the first two? Because I have work and I emailed you. You told me to email back, but you never graded my quiz too.
Oh, which one quiz two? I will check, you know.
Okay. Yeah,
So
I sent you an
because-
email about it.
Yeah, because I don't have a TA, and then we have class every day. So the previous, all of my class, I had a TA to just help with grading, solution about homework or quizzes. I need to do them all of them myself.
Yeah, okay.
So
Yeah,
it
no,
takes
thank you.
time.
No, yeah.
I'm so sorry, be patient with me. So I don't have a TA, so. And the class is like 30 something, so it takes time.
Professor, I have a question on quiz 4.
Sure.
So in the solution, they use the master theorem, but in the lecture, you told us to use like recursion tree and substitution and then induction. So which one are we supposed to use? Is it both okay or?
Both okay, yeah, that's okay. If somebody use other, I just grade them. But the things that about quiz, I think quiz 4, I think I grade quiz 3. I don't know. I didn't grade quiz 4 yet. So yeah, if you use any other method, that's fine. As long as everything is so okay. Let me explain something. Quiz 3, I graded, but you guys didn't prove anything. You just write okay because A and B, so it's C. It's not gonna work like that. As I explained in the class, you need to just write them one by one. For example, there exists a C because of that this equation hold. You just not can just assume everything is correct and just write it. So probably I grade all of you guys and saw that so many of you. So just write okay. Like for example, say, let me see. Okay, f of n is greater than g of n, and g of n, for example, is O of, I don't know, L of n, and that's okay. Because, I don't know, h of n is less than L of n, so, and then the first one, and then we prove, okay, f of n is O of Ln. It's not gonna work like that. You cannot just write this one, it doesn't make any sense. Because of this, there is need that everything needs to be written. So there is exist a C, because of that C, this gonna have, this is not what you need. Or just you write this one C, and it's okay, we consider C is equal to 1, that's it. No, when you prove it, you cannot consider C is only equal to 1. You should know there is an and not, and because of this and not, this C exists. So please make sure write all the details. So other than that, you see lots of you lost a lots of point because you didn't do a job. You just write it one by like this. It's not gonna work if you do it for final exam. Does it make sense? Is it clear? Yeah, make sure you write everything. So I just typed midterm today. So I just type all the questions. We have 4 questions. Because I just want to help you guys. The grade is 110, 10 extra point, just helping. So you have 10 point extra for just for the midterm. Actual grade is 100. I just had the exam for 110. Does it make sense?
Yeah, that makes sense.
Yeah, I just add 10 point extra, just helping you guys if you just get a better grade. So, and then make sure everything, because it's open book, it's like start at 5 and finish at 7:15. Make sure the last 15 minutes, I put the last 15 minutes not for solving a question. I put the last 15 minutes just for submission. Please don't wait for the, I don't know, 7:15 pass and let me know, oh, that we had the issue. I don't know. I couldn't submit, I couldn't upload. Just make sure you just start at 7. You have 15 minutes to upload. Does it make sense? This last 15 minutes is not for solving a question. This is for only uploading. No, you
That makes
cannot
sense.
you cannot get 10 more on top of the 10. Why? Why should I give you more than the others? What is the difference? So, okay, that's the thing. And okay, one more thing, please join at 5. Please don't join late because there is like a midterm code again. So if you join late, you will miss some of the time. So please make sure you're just joining on time. So, and then probably if I'm gonna be in the Zoom call for the whole 2 hour and 15 minutes to respond to any question you guys have and anything's happened. So probably it's better to stay in Zoom call because if you have any question for clarification, you can ask. That makes it easier for you guys. Just don't wait for after the exam, like the quiz, and say, okay, we didn't understand the question. The question is really pretty clear. I just try to write it really clear there, but just want to make sure. And then we have four questions, and each question have part A, B, C, and we make sure just consider time. If you see one of the question is hard, start with the other and go back. The question start with, we do have induction question. We do have growth rate, which one has the higher, which one has lower, the one that I solved the other day. And then we have the algorithm problems, like that you write about sorting problems. So you write a proof, do the induction, show the correctness, show the correctness, and what else? What was the other? I can show the correctness. Anything else? Okay, show the correctness, and then okay, find asymptotic runtime. This is all for the algorithm question, and then this is the first, second, third. I have one more question actually. What is the last question? That's okay, recurrence. So prove, find the Tn runtime, you find this one. This is the 4 different kinds of question we have. We have one question for induction, we have some growth rate questions, so which one has the highest, which one has lowest. You have one sorting algorithm, then you should show the correctness, and recurrence find Tn. Probably, as I mentioned earlier, you guys need to remember some of the topic from the notes in the class. Make sure at least you have a note for yourself. If you need to know which session or which class, for example, sorting was from lecture 9, 10, or 11, just make sure you are ready, because 2 hours is not enough to go back and forth. It's open book, but it means you need to be ready. Just make sure 2 hours for this kind of question, you need to be ready, because it's open book. It doesn't mean you don't need to read. You need to be ready. Other than that, you are not ready and you don't know, for example, what is finding T of n means, or how to show correctness, or how to show proof to find them, like what is the master theorem. If you don't know these things and you're not ready, it takes a long time to just go back and forth, and 2 hours won't be enough. Does it make sense? Is it clear? Yeah, I just want to make sure that you guys understand this. Don't wait for the tomorrow and just see that, there is not enough time for this kind of question. Be ready, have some of the notes, for example, what is like big O or something like that. And then it's easier to you can use any resources I mentioned, but if you copy paste something, just if it's not your work, just cite them. So, okay, I use this part, for example, this theorem from this part. And then, yes, that's it. I think that's what it is for the tomorrow. So if you have any question right now, so I tried my best to type everything in detail for the homework, like quizzes. Please go through them. So maybe some of them is helpful for the final exams, for the midterm. So everything is there. If you have any question, just you can ask right now or after the class. So probably it should be clear. I will donate quiz 1 and quiz 5. I will grade them too. And when I grade them, I post the solution too. Probably I will try my best. I don't know. I will post the solution tonight or tomorrow morning. So at least you guys have the solution for that one. One of you, I saw some of the emails. I didn't have a chance to respond. I think one of the students ask about the final exam, if it's in person or in the, like it's gonna be in Zoom. I don't know. It depends. First of all, if university provider proctor or someone to do the exam in person. And then the other thing, let's see how do you guys do on the exam open book. So if you do, because as I mentioned earlier, open book is harder than just closed book, because if it's closed and if you are just writing, it's easy. This question probably would be easier. So let's see how you guys doing on this one, and then I will decide about final exam. Is it clear? Any question, any comment, anything you need to talk before tomorrow? Anything you want to add about, like, do you have any question, any issue? Let me know right now. So, okay. One of the students have asked, he has a question, I don't know. Send him direct message in Zoom. Probably if you have a question, it's better to ask right now. How was the solution for homework 1? Did you look at them? So did you learn anything from it? Was it useful? So probably I tried to write as detailed as possible.
Hello.
Hello?
Hi, I joined a little late. but I was wondering, for quiz 1 and 5, it wasn't letting me re-upload.
Oh, that's fine. It's okay. It's like I don't know what happened. I tried to grade on Saturday and it shows me that there is no submission for any of you guys. That's the reason I posted again. So but probably if it doesn't allow you to resubmit, that's fine. I just allowed to do resubmission, multiple submission. I don't know what happened. So probably if it didn't and if it used the previous version, that's fine.
Okay, thank you.
You're welcome. So anybody has any question? If you don't have a question, so before like anything about tomorrow or anything you need to know, let me know right now because I want to start teaching. We want to finish the sorting algorithm that we started.
I have a question about the homework solution.
Sure, go ahead.
For the first one, you used limits to solve. Is it okay if we didn't?
Why?
For the first problem, you use limits to solve. Is it okay if we didn't?
No, yeah, it's okay. If you do you use the proof? Do you use the C? There's exists a C and not.
Yeah.
Okay, that's fine. That's
Okay.
fine. Yeah, you can use any of them. Any of them is fine. And then one more thing, I don't know. Some of the students, I don't know if that person of 2% is still in the class right now or not. They don't submit any quizzes at all. So no submission for anything, no quiz, no homework. Do you think these people are dropped or I don't know? So probably if you are any one of these students that there is no quiz, no homework, probably I don't know what's going to happen. So because there's some portion for homework, quiz, and the other things, you are missing a lot. So just want to mention that too. Okay, let's go. So you don't have any questions? Should I start? No question.
Professor, did you find out if the final is going to be taken online?
I think you joined late. I explained because I need to know if the person that is I asked question in university most of the time, she didn't respond to me yet about TA anything. I don't know what's going on. And then I need to know if anybody can be proctor that day. Or another thing, I need to see how you guys doing on your midterm, like open book midterm, see how it's gonna go. So.
All right, sounds good.
Yeah. Okay.
Thank you.
You're welcome. So, okay. One more thing, if you have anything you need to know about the midterm or you need some assistance or anything, contact me today or I don't know, 3 hours before the exam. Don't wait after the exam, please. And I know one student reached out to me. I will respond to him. It's about like his flight or something like that. So just want to know if he's in the class. I will respond to the email. Okay, let's go back. I think we'll start with quicksort. Again, we are talking about like
Can I ask a question real quick? I'm sorry.
Sure.
Did I remember? Did you say that quicksort was going to be on the test or wasn't going to be on the test?
Quicksort is not.
Oh, okay. Dang, I spent all that time studying quicksort for nothing.
No. The good thing is because in the quicksort, this is not, it means that this quicksort be in the midterm, but you need to understand this kind of question for solving the question in midterm. Probably you don't waste your time because you need to understand how this is structured. You remember I explained, okay, about batch sort that we explained, you need to know what is the T, how to prove the correctness, how to prove the what is the TN, the recurrence, and then prove that's what is going to be the runtime. Probably you don't waste your time. So you just understand.
Yeah, I see. I have one more question. What's backsort?
Backsort was the one that I explained on Thursday, last Thursday.
Oh, I remember. I think I just misheard.
Yeah, backsort, the one that I uploaded the previous lecture 11. And I told you guys that midterm question was like that. Probably you guys missed that one, so I explained everything on that day. So I chose midterms probably quite the same format as what I explained on Thursday. Probably worse. That's the reason I uploaded fast, so probably it's worse to go and look at it again. Okay, make sense? Yeah, exam can be online because everything is online, yeah, but we need to see how you guys know. Probably, let's see how it works. Or probably make it for take home. So, okay, let's see. We talk about quick sort. Quick sort is A, P, and R. So what is quick sort? So this is A, P, and R. So when we do quick sort, as I explained earlier, how it works, we say if P is less than R, what do? We do Q, which is gonna be partition. I think let me see, I think I already finished quick sort, am I right? I think we've missed induction, we finished quick sort. Let me see. Did I finish quick sort? I don't know who told me that he read the quick sort in detail. Are you in the classes still? Did you guys read the note at all? Nobody in the class?
The notes that you make during lecture?
Yeah, during the lecture. What was the last thing that I taught in the class? I think you guys should be probably ready because you have midterm tomorrow. Did this class read anything? So interesting. Now I'm worried for you guys. So.
Wait, what's the question here?
I think I remember we learned the first
I
part of
think you
quick sort.
finished quick sort actually. That was my question. Did you finish quick sort or not? I think
I
I
don't think
probably
we got through the whole thing because we started doing midterm review.
no. I think I finished quick sort. I start inversion. We didn't finish inversion actually. I finished quick sort. For inversion, let me see. We do the comparison. So, simplify this. Oh, okay. We didn't finish quick sort. Yes, we talked about quick sort. We explained the partition, and then we pivots, and then what else we didn't finish? It was like we didn't exercise. I was right. We didn't exercise partition. Just want to make sure. One more question. Does anybody in this class really ready for the midterm?
Can you say that again? I'm sorry.
Does anybody in this class ready for the midterm? Because none of you guys responded to my question. I'm wondering if anybody read the notes or anything.
I think I'm ready.
Yeah, probably you guys need to be ready. And then if you don't engage in the class, I don't know if you read anything. Okay, sounds good. So please respond to my questions. At least are you guys in the class. Okay, so we talk about quick sort. We say, okay, if P less than R, so what we do, so this is gonna be inside. So just wanna make sure that we go in, like it's gonna be Q. You find the partition, A, P, and R. And then we do quick sort. sort of what? A, P, and Q minus R, 1. And then we do what? We do quick sort for A, Q plus 1, and R. So we just do all of these things step by step. We didn't have everything, but one of the things I explain about and show one example, and then everything is ready. But the only thing is we didn't talk about how the partition works. What do we do about partition? We find the Q and then we work, okay, quick sort this part and then quick sort after the other one. Let me bring everything up. Let me do another example because probably you guys forget how the quick sort works. Let's bring up your memory about how the quick sort works. Okay. Let me see. Okay, let me start with the example. So. And then let me explain how the partition works. So you remember I explained about quick sort. I say, okay, I have A, which has 9 minus 3, 5, 2, 6, 8, and then minus 6, 1, and 3. I say, okay, let's consider this one as a pivot. And what do? We put the pivot in the middle. And everything before and everything after. Everything before is going to be smaller than this number inside, like this one, which is going to be, what is going to be? Minus 3, 2, minus 6, and 1, which is going to be less than equal to 3. And then let's consider this one. What is going to be this one? It's going to be 8, 5, 9, and 6. And this one is going to be this one. This is going to be greater than 3. So now let's go to one layer down. As you can see, what we did, we say, okay, if it's less than this one, in the Q is on a pivot, and let's go, okay, before this one and after. And now we do quick sort this part. Okay, let's consider 1 to be pivot. And let's do this one again. Let's put 1 here. Let's consider everything less than 1, which is going to be minus 3, minus 6. And let's consider everything bigger than 1, which is going to be what? It's going to be 2. So this is going to be less than 1. This is going to be greater than 1. But that's the first part. And then let's keep going. Okay. How about here? The pivot is going to be what? Minus 3. And here before this one going to be minus 6, and there is nothing before that. And then we move from here, minus 6, minus 3, 1, 2, 3, and then let's see, let's calculate this way. This way, so if I want to calculate again, I consider this one, as a pivot. Okay, 6 in the middle. Let's consider everything before 6, which is going to be 5, and then everything after 6, which is going to be 8 and 9. And then we do here, so let's do 9 as a pivot, so everything before 9 and everything after. So if you consider, it's going to be minus 6, minus 3, 1, 2, 3, 5, 6, 8, 9. So that's going to be the structure that it works. Does it make sense? Every time we find, for any part, for this part, we find the pivot, and then everything before the pivot, everything after the pivot. And then again, we go one layer down, down, down until we finish it. Does it make sense? Do you guys understand? I understand this quick sort, just reiterate the quick sort. So everything is going to reiterate by itself. That makes sense. But we need to understand how the partition works. What does partition actually do? Does anybody know what does partition do? Look at here. What does the partition do? Actually, partition is this part that put something before, something after. So we need to write, I know I am explain here everything, but I need to write it in like a pseudocode. We say partition arrange P to R so that, how it's just arranged, so that what? Let me see. We say all the things in like a pivot, everything before the pivot, everything after the pivot. Let's take all the A, Q plus 1 up to R, and all the A, P to Q minus 1. But this part is not sorted. And this part is not sorted either. And then what we know that P, Q is between these two, because P is the start point, R is the last one. So we say where P is this one. Okay, if that's the case, I want to find a pivot, and then everything before is going to be small, everything after is going to be, sorry. So everything after is going to be bigger. Let's explain everything here. Let me write the partition actually. So we want to write the partition algorithm. Say partition says A, P, and R. How it works, let's write it step by step. First of all, I say, okay, I consider I to be P minus 1. It means the start before that one. So I say, okay, 2, it's like for J from P to R minus 1, it means go all the way to the end. So what do? You say, okay, if AI, which is the previous point, is less than equal to AR, if it's less than, so what does that mean? We start from the previous value. For example, here, if you start with previous value, it means you say I is P minus 1. If the pivot is here, I look at everything before. So it's like I minus 1, and from P to R minus 1. So okay, you consider f of I less than f of AR, it means that they are in order. If they are in order, it means everything works. It means this value is less than this value, because this value is a smaller, if the index is a smaller this index. So if that's the case, so don't do anything, just do I plus. It means that's already sorted. If it's, and then what do? We just swap that one. Swap this value, because this is smaller. So let's do the swap. And then if it now wasn't the case, what do? If you do and everything is finished, 3, 4, and 5, this is number 5. In number 6, it means that this for loop is finished. What I'm gonna do, I put the last one. I'm gonna swap that this one with this one too, with the last point. And what I'm gonna return I plus 1. Let's see how it works. Let me show you guys. Okay. Let's write everything, makes everything easier. I say, okay, I have I plus 1 all the way to J minus 1. I have AJ all the way to I. Okay. Probably I need to write it smaller because we have a lot of things. So we start with AP. It means A in index P. So it means A in index P. So we just go all the way to AI, which is this index. We have AI plus 1, all the way go to AJ minus 1. And then we have AJ is all the way to IR minus, and then we have AR. That's it. Okay. So we say this last point is the pivot. Every time I remember, we talk about this one in example. This is the pivot. So what I'm gonna do, I know this part is unknown. This part I know is less than AR, and this one is greater than. This one is greater than AR. Okay, so how it works, so we say, okay, note if AJ is less than AR, you can see here, if AJ is less than AR, because we need to swap, because we want to have an order. So what we do, swap. And then what else? And then we do I++ and J++. This is the first. This is the first one. And then we have another one. The second one says, if AJ greater than AR, there's gonna be J++. Okay, but what is all of this means? I say, okay, I consider this definition. I say, okay, I do have all the A, I start from AP to all the way to AR minus 1A. So it means, what does that mean? So if I have an like list, let's put this list. It's two. Let me actually use the one that already we just thought. Okay, my A is something like this. A is what? It's 9 minus 3, 5, 2, 6, 8, minus 6, 1, and 3. Does it make sense? That's the first A. So what does that mean? If I consider this is AP, which is gonna be A0 because P is 0. And this is gonna be AR, which is gonna be 0. It's gonna be A9. Actually, we consider this one A1 because we index 1 in here. So it's not 5. So okay. So we said first algebra, the first indices is 9. It means P is 1. And then the last one is R, which is gonna be 9. So that's the way we do it. Does it make sense? Is it clear? This is the A. I will explain everything here. This is the A. This is the first indices. AP, it means A1. This is the first indices. AR is the last one, which is going to be A9. Does it make sense? Okay. If this makes sense, what do we do? First step, close the pivot. What do we consider for the pivot? We say consider the last one. So AR, which is going to be 3, is the pivot. Okay, the partition do something like that. They say, okay, put this part, everything less than AR. Here, everything greater than AR, everything. And here is something unknown, we don't know yet. And this is AR. AR is gonna be the last one. Okay, if I consider everything before this one, okay, I start with I. What is the I? I is P minus 1. It means I is gonna be what? I is gonna be 0. It means I start before everything. It means it's go out of this one. So I is equal to 0 for the first part. Say, okay, I is equal to 0. J is gonna be P. P is gonna be 1 to R minus 1. Everything from here down to R minus 1. Look, we look at the whole data. What we do? We say, okay, if that number is less than R, move forward. If it's not, move it. What does that mean? Okay, I look at this one, 9 and 3. Is 9 and 3, is 9 is less than, is 9 is less than 3? It's not. What I'm gonna do, I'm just gonna move this one. I'm just gonna I plus column, which is gonna be 1. I'm just moving IJ, J is P with AI. So this is the first one, it doesn't change because 9 is the 0. So it's gonna be 1 changing by 1. So it's not gonna change. Let's go to the next one. And then we do the next one. Let's the next one, you check the JP to R minus 1 again, here, minus 1 to 3. We swap down. So probably what we get here, so eventually, we gotta have some data being here less than this one. It means we ended up being minus 3 here. We have minus 6 here. And And then what do we have here? For example, everything greater than 1. This is going to be 9, 5, like 6 or something. And other things we didn't consider, everything is going to be here. We don't know what's happening. Here, we just put some numbers based on just comparison. So -3 and 3, okay, they are smaller, so put it here, keep it here. If it's bigger, move it, and then we swap it. This is unknown one. Every time we go through this one, we switch this unknown one. And then at the end, we check this one. We say we'll move these two. Because we know that 3 is the smallest one, we need to bring it here. We just put it here, you know? We just move it. So that's the way it does work. And then we return this unnumbered, I plus 1, because we moved that number 3 there. Does it make sense? Just what you do every time, like exact same thing here. We consider this thing, everything before, everything after. But when you do partition, you actually don't know where they are. You just consider everything smaller, everything greater, and everything unknown. But this unknown is this loop. This unknown, this is this loop. Every time you move one data at a time, and just you find the pivot before you find the I plus 1 for this next, because I plus 1 is the partition. For the partition for this Q, which is going to do the quick sort. Every time you find which number should be, we move forward, back and forth. Does it make sense? Does it make sense? So that's what we do. What's a step? So, okay. If AJ is less than AR, every time you check, swap that one with this previous number and just do I plus plus. If it's not the case, just do J plus plus. Okay. What is happen actually? We say that loop through 5, maintain following invariant. First, J should be between I and R, which we know based on the equation. And then all the things P to I should be less than AR, as we know, as I explained earlier. AR should be less than everything from I plus 1 to J minus 1. That's what we do. And then last one, for everything from J to R minus 1, it's not processed yet, has not been processed. Like what did you say example here? When I say pivot is 3, I know everything here, like from P to I, is less than pivot. Everything from this one to here is greater than pivot, but we don't know what's, for example, if something is missing, we don't know, we didn't process. Here, we just already processed it. So what that follows, does anybody have any questions? Did you have a question? Because of this case, because we do these things, we find this pivot based on this structure of the partition. We know everything before this I minus 1, as I can say, this is I, it's gonna be less, and everything after this one, the J is gonna be greater. So we know these things. Everything before I, before which is gonna be, I is gonna be Q. Everything before this I is gonna be or less than this pivot. Everything after is gonna be greater than pivot. We do all of these things. That's the reason we know it's gonna be 2. The reason I put this one q minus 1 and we return I plus 1 is here because I plus 1 with q minus 1 is become I, which is going to hold this one, p to I, and this is going to be, when we have this one is going to be q plus 1. So that's the reason we have that one, I plus 1, and here we have mine. So that's one of the things. So we just consider this one. Okay. So nobody has any question up now, am I right? Okay. We said if M is gonna be exact same thing for proof in induction. Say the length is gonna be, we consider M, the number of input, is gonna be length of what? It's gonna be length of the array from or list from A, P to R, which is gonna be R minus P plus 1. Then we send then partition of A, P, and R does exactly M minus 1 comparison. But isn't then this one does exactly M minus 1 comparison? Okay, it means all the cases, in best case scenario, it return best M minus 1. In worst case scenario, it returns M minus 1. And in average cases, it means return M minus 1. Why? Because every time you have an array of AR, you just consider, if it's N, you just do all of them. You just compare everything before that. So if we say top level, it means that we need to consider that one. We say top level. From 1 to N, if I have N number, does N minus 1 comparison? Because we just do everything before pivot, everything before pivot. So if the number is N, so we have N minus 1. You know, when is the worst case? Can anybody tell me when is the worst case scenario?
Sorry, worst case what?
What is the worst case? When we do this partition, we compare everything to see, okay, if anything like here, before AR, before the pivot, is it smaller than the pivot? Is it bigger than the pivot? So what is the worst case scenario? Because we just do comparison one by one. We have N minus comparison. But what is the worst case scenario? When is the worst? When you need to do all of this stuff? When is it? No, we don't need to swap everything, but you need to just check one by one because everything is in the order. Let me show you guys something. It's a worst case scenario. Occurs when, let's see, we have the array is already sorted. Already. What do you do? Because you see, all the things I do have R minus 1 is already in order. Everything is less than R, if this one is Q, and everything after is empty. There is nothing after. Because I need to check everything before Q, every one of them, because everything is smaller. So that's the worst case because it's already sorted. But let's consider T of N. Let's say we want to consider T of n. T of n is all the time I explain T of n, which is going to be runtime, is worst case. I told you guys that best case doesn't make sense because we don't want to know what is the best case. We want to know what is the worst case. So worst case is number of comparison. As you can see, if I consider, that's why that's the worst case. If the last number is bigger than the other, I think to compare all of them one by one because everything is smaller. So then the comparison by quicksort. When we have our arrays from 1 to n is sorted, this is the worst case scenario, as I mentioned. So T of n is going to be number of comparison by quicksort when it's sorted. How it works? You say, okay, I'm just consider T of n again. I say if n is 0 or 1, if it's 0, there is no element. If it's 1 element is already sorted, so there is no way. If now n is greater than 2, it means I do have more than 2. What's going to happen? First of all, I have n minus 1 number for each comparison. If I go here, I do this one. Every time I just check this partition, I do n minus 1 because of this loop, and then I have T of them because it's sub partition. So I say, okay, the number is going to be T n minus 1 for every time, and then I do it for every iteration. It's going to be T minus 1. So iteration, so if I do iteration, so I explained earlier, like this happy face, smiley face is going to be T of. So we need to do this thing, like iteration method. We say what? We say T of n, it's n minus 1 plus T of n minus 1. I put a smiley face, it's going to be T minus 2 here. Let's put it first one. Because we just put n minus 2 plus T n minus 2. Let's keep going. And at the end, it's going to be n minus 1 plus n minus 2 all the way to 0. Because we just do it one by one. Because everything is going to go, and then we are going to reach the point, which is going to be 0, and then T of n is 0. So this is going to be the result, is going to be T of n. The summation of everything here from n minus 1 to 0 is going to be n minus 1 divided by 2, which is going to be theta, because it's going to be n squared. It's going to be n squared minus 1 over 2n. So if you consider n squared grows faster than n, so it's going to be theta of n squared. So that is 1. Okay, that's the way that we did it. So, but quicksort, as you can see, is not faster than the merge sort. You remember when we talked about definition of merge sort was q n log n, and I explained like between n log n and n squared, which one is better? So n log n. So we say, okay, quicksort is not good because quicksort has n squared. So probably if I want to solve the algorithm, I'm going to go with like what? I'm going to go with merge sort. Why do I need to do quicksort? Because quicksort is not good. Does it make sense? So that's what we do. We say if it's not that great, so we don't do it. We just use this one. Okay. You guys understand this one coming from where? You know where this is coming from. Am I right? This is from quicksort. You know how it's coming from? If I go to, let me clarify one more time. So here, I understand partition has the cost, the runtime. I explain runtime in the worst case scenario is n minus 1. Because why? Because we say we compare everything to each other. But here, this cost is 0, as you know, there's no cost here. This cost is coming from partition, is n minus 1. This one is gonna be t n minus 1, because this is gonna be 0. Why? Let me go back here. Because we consider worst case scenario. Worst case scenario, everything is before q, there is nothing after q. There is nothing after q. So if there is nothing after q, this means that there is no cost for this one, because there is nothing in there. So this is gonna be 0. Everything is here. N minus q is already one number. So our number is n minus 1. So we have t, because it's called the quick, so it's gonna be t n minus 1. Does it make sense? Is it clear? Because you consider the cost all the time. So okay, there is no cost here. I know partition has n minus 1. This quick sort has how many numbers? It has q minus 1, which is going to be n minus 1 number. The quick sort is t of n. This is going to be t n minus 1. This is going to be empty. There is no cost for empty. So, but let's see. This is the worst case scenario. How is the average scenario? Let's go and find the t of n for average scenario. So we realize, okay, quick sort is not good if we do have a sorted algorithm already. But how about if we don't have sorted algorithm? So let's see. Okay. Okay, we name it quick sort. So it means something is quick about it. What is quick about it? Let's talk about average case. Average case says we assume all n factorial permutation of input array A1 to n are equally likely. It means it's not sorted, but they are like definition of all different. For example, if it starts, sometimes 2 is the first one, sometimes minus 1. It means all of them has a permutation. It means the way that we consider it together. So if this is equally likely, we say let f of n, let's put t of n actually. Let t of n be the average case number of comparison of quick sort. What does that mean? I say, okay, worst case scenario, it means when everything is smaller. So let's see. I have 1, 2, 3, 4, 5, 6, and minus 1. It means this is the pivot, this is the Q. I just compare everything with this one by one, because everything before is already sorted. But okay, if I consider instead of this permutation, I just consider different permutation. For example, it's likely to have minus 1, 1, 2, 3, 4, 5, or the 2, 1, 3, 4, sorry, 4, 3, 5, minus 1. This is another. It means the likelihood of any of these is going to be equal. So you want to see if any of this happens, what is going to be the runtime. So we say if they are equally likely, we get average because any of these things happen. We say average case of numbers of comparison for quick sort is going to be what? It's going to be T of n. It's going to be summation of all permutations. Because if permutation have number of comparison, let me see if I can write this smaller. So T of n is equal, it's gonna divide by n factorial because there is a permutation. So okay, this summation for all permutation It means anything's that's gonna happen. There's gonna be number of compare permutation on giving permutation. Okay, number of compare number of compare on given permutation. So it means we look at every. I'm so sorry, it's really bad. So what's going on? Given permutation. So number of comparison for any of them, because if you have this one, if you have 1, 2, 3, 4, 5, -1, this one permutation, there is number of comparison that we need to do here. If we have it -1 here, we have another. So that's the way we calculate T of n. And then what is the goal? The goal here is to find a reoccurrence for T of n, because now we don't use any theorem or anything. This is going to be really hard. How do we want to go forward with that? Does anybody have any question? Okay. We said, okay, I want to consider, I say, our assumption, what is our assumption tell us? Our assumption was that any permutation is equally likely. It means any of these things gonna happen. Implies, what is implies? That the return value Q of partition is equally likely to be any of the values. Because we say, if its permutation is equally likely, because every time the last last element is going to be Q. So it's Q can be anything, any of the values, because it's equally likely to have any of them. It's going to be 1, 2, 3. The indices from 1 to n, Q can be any of them. Okay. It's like a probability. So the probability of Q is equal to I, any of them, is 1 over n, because it's equally likely. If you have n number, it's going to be equal for I from 1 to n. That's what's going to happen. Also, what we have, also, we say partition A1 to n does n minus 1 compares. We know that if you have all of them, it's going to do this one. And then the length of them, A from 1 to Q minus 1, what is going to be this one? What is this? What is this length? Anybody? I explain it another time. So what is this length? How do we consider this one? What is the length of this? It's gonna be Q minus 1. Go ahead.
I was just gonna say Q minus 1.
Okay, yes, because we say Q minus 1 minus 1 plus 1, which they are removing each other. It's gonna be Q minus 1. So, okay. And then what is the length of the other one? Length of A, Q plus 1 up to n. What is the length of this one? Anybody?
N minus Q plus 1.
No.
Minus
So how
1.
do we consider this one? Say n from the last one minus the first one plus 1. So this is going to be n minus q. This is the way we calculate this one. The last one minus the first one, and then we plus one. So that's the way. And then if this is the case, and then we go and calculate this all summation, we remember we say T of n is n factorial, which is gonna be, we put it as n because we remove all the permutation. We say, okay, all the permutation, summation of all of the permutation. We just consider these three. It's gonna be the summation of what? It's gonna be q from 1 to n. One of them is n minus 1 because we do have this first comparison. And then what we have? We have t of q minus 1 and t of n minus q. That's coming from here, you remember? If I go this cost here, this cost, the partition is n minus 1. So this is gonna be n minus 1. This is gonna be what? This is gonna be q minus 1 because of the size of this one, and the last one is going to be n minus q because this is n, rn, this is going to be q plus 1. So that's going to be the calculation. So we do have this summation. So this is the case. So, and then we just prove it. So if we calculate this one, if the summation, so this is going to be n minus 1. It's going to be n minus 1 plus 1 over n, the other one, which is going to be q plus 1. This one doesn't have any q, so n is become outside, and the other one has q. It's going to be q to n, q minus 1 plus 1 over n, summation of q from 1 to n, t n minus q. So that's the other one. Okay, how we consider this one? So if q is 1, what's going to happen to the second one? Consider q is equal to 1. What's going to happen here? If you put q, what's going to happen? Q equal to 1. Anybody? If you put q equal to 1 here, what's going to happen? Okay, yes, if q is equal to 1, the summation is 0. So it means that we can remove q from 1, we can put it 2, because that q equal to 1 doesn't make sense. And how about the last one? If we have q equal to n, yeah, still it's gonna be 0. So because, okay, q1 to n minus 1, because if I put n, it's gonna be 0 again. So it's gonna be n minus q. So we already do this thing. So let's see. Okay, what we can do, if you remember math, if you have here this one q minus 1 and this one q, you can change the parameter. This one become, this is gonna be the summation of this one, q equal to 1 to n minus 1. This is gonna be q. So what you can do here, so that's the t of q. Just do different, like instead of like you putting like q, just change the parameter, and this is gonna be tq. Just put this one. It's a minus 1, put it tq1, and this one is become tq. So that's the way it does. The reason I put it like this because I want to put this summation together. If that's the case, now I have my t of n is equal to n minus 1. These two they are equal because this is going to be q from 1 to n minus 1. So this is going to be tq. I switch this one too, because I can switch n minus q with this one. This is going to be exact same thing. So that's the other way. So we do this one. So this is going to be tq2. Just change this one. This is going to be n minus 1, that one. So you just should switch that one. So if that's the case, so we do have this one. So actually, there's going to be 2 of them. And then if we consider the solution for this one, for this example, we say T of n, it's going to be 2n minus 1, h of n minus 4n. You need to calculate. This is going to be an example of how the calculation works. This is going to be the n, the solution is the n harmonic number. Which one is the plus or minus? This one, 2n plus 1. No, this is the solution. I know this is n minus 1, but we need to solve it. There is one tn here, there is one tq here, you know. That's the reason you need to switch it. This is gonna be the way. This is gonna be the solution. This is the solution of T of n. The harmonic solution is going to be this 2 plus 1 hn. And what is the hn actually? It's going to be summation of r from 1 to n, 1 over r, which is going to be 1, 1 plus 2, and all the way 1 plus 1. You see, this is the n harmonic when we say h of n. It means the result is going to be 2 of n plus 1, the harmonic minus 4n. That's the definition. We need to keep going because this is not prove anything for us. I know this is the solution, but I need to find the asymptotic rate. So if that's the case, so I say, okay, I know that if this is the result, this is going to be h of n plus something. And then I need to consider estimate size of h of n. So I consider h of n. So what I got, so okay, I know that h of n is less than 1 plus ln of n, and this is less than, greater than ln of n plus 1. So that's the definition. So because as I know, h of n is big O of ln n, and then h of n is big omega of this one. Oh, sorry. This is going to be 1 plus n. And this is going to be, this is the definition. So based on what, no, this is the definition. If that's the case, so it means that h of n is q of ln of n. So if I put this here, we say T of n is 2n plus 1, h of n minus 4n. Just remember, if you have anything in midterm, something like that, you reach to this point, you reach to the point that you have T of n, but T of n, you know, like has a relationship with another function, which is n of n. So it means T of n, it has like relationship with each of n. It's like you need to know that the time of this. You need to find h of n asymptotic notation and use it here. So I need to solve this one first. So that was the case. So what I had, okay, I know T of n is 2n plus 1, h of n minus 4n. But this one is another algorithm depend on n, which is going to be parameter of input. So we need to calculate this one. We show this one is going to be TED of ln. So I just show that because, you know, h of n, if you consider that one, do the plot, you know, it's between ln plus n plus 1 or ln. So this is going to be greater than ln. So, and it's going to be less than this one. So it means it's theta of ln. If that's the case, what should I do here after I know this thing? I will put it there. It means substitute that. It means T of n is 2n plus 1. I know what is h of n. If you know it, I know it's theta of log n minus 4n. Now I need to just calculate this one. So this is going to be T of n. This number is compare n with log n, n log n doesn't matter. So this is going to be theta because n multiple, this one is going to be n log n. That's the way we reach it because n log n. This is asymptotic. With a quick sort, in average is like merge sort is n log n because T of n is like approximate to this one, to n log n. Because we remove this one is not important. This 2 is going to be like this. So that's approximate. In practice, actually, we randomize quick sort. Why we do that? Because if we know it's sorted, it's going to be worst case. But if we know it's randomized, it means everything has equal like equality to happen. So we randomize quick sort to we get to the average point. If we get to the average point, it's going to be n log n, which is going to be average case runtime, which is going to be good. It's going to be quick. So that's the reason we put the name to be quick sort. Does it make sense? But I can explain how do we reach from this one to this part. Let me maybe draw that one. If it's clear, let me draw that one. Does it make sense? Okay, we say what is it? We say h of n is what? Is the harmonic is from r plus 1 up to 1r, which is going to be 1 plus 1 over 2 plus all the way up to n. Let's draw this. When we are in 1, what is it? It's going to be 1. When I'm in 2, when n is equal to 2, it's going to be this one, 1 over 2. I just moved everything. If I'm 3, let me make it actually bigger so it's easier. When 1, it's 1. When 2, it's 1 over 2. When 3 is 1 over 3. And then when it's between n and n pi plus 1, it's going to be what? It's going to be 1 over n. 1 over n. As you can see, we do have these things. We do have these 1 to 2, 2 to 3, this one. As you can consider, this is this summation, this is this harmonic. So if I consider this log, so if I do consider this one, so this is gonna be, this is the log. So you can see it past this part. This part is look like this. It's gonna just compensate. So this is means that if this is 1 over x, which is gonna be the plot, so we say, okay, this is because this is if it's under this graph is everything's under this graph is gonna be the solution for us. It's gonna be the integral of 1 over n plus 1 because we go all the way to n plus 1. 1 over x d of x. So it's gonna be h of n because h of n is less than this number. If we do because h of n start from here, it doesn't consider this part. So it means h of n is between this one and 1 plus that one, because this part is only, you can see this part, the first part is 1, it's gonna be 1 plus 1 to over n 1 xd of x, because it's moving from here to here. If that's the case, this is gonna be the case. So that means h of n, this is gonna be what? We consider this one. This is gonna be L n plus 1. If you calculate this one, this is gonna be 1 plus Ln, which is gonna be again upper bound NL, lower bound Ln2. So probably that's the case. So we can say, okay, this is gonna be between theta of Ln of n for h of n. Do you understand how I consider this, where we reach to this point? Does it make sense?
Yep.
Okay, I think sounds good. So I think I explained everything. Let's give us 2 or 3 minutes, 5 minutes for rest, and then let me just do a few, maybe one example about, because this is one of the part of the things that you have in the exam. So if you have like this, like you have theta of n belongs to related to another. You have one question mark from. Maybe I will solve one question here for the reference. Sounds good? Okay. Anybody has any question up to now? You don't have any questions? This is not part of the midterm, but this part that if you have like any any T of n related to another H of n, which is have another runtime, how do we solve it is like this. So we do have something like this in tomorrow's exam. I just want to make sure you understand. No worries, that's fine, that's okay. I understand, that's fine. Let's keep you guys 5 minutes break. So, and then I will explain one example for tomorrow's exam. And then we will meet tomorrow. Just have 5 minutes. I will mute and then we will talk. Does it make sense?
Chatty. Chatty buddy.
Thanks.
Can you hear me?
We can now.
Yeah.
Do you guys have any questions? Anyone has any questions? So I heard that you guys talking.
No, somebody just had their mic on accidentally.
What?
Someone just had their mic on accidentally.
Okay, I see. Okay, let's explain a few things one more time. So if I do have like this one, how do you calculate this one? If I know, if I have this equation, so if I do have this equation running, so and I know E of n, I go and find, first of all, I need to go, because this T of n depend on E of n, I go and find T of n, and I realize, okay, T of n, what I can do, so okay, let's see, let me write it again. So we have this T of n, it's n log n, E of n, plus n squared, for example. First of all, what I need to do, I need to find E of n. Things that I found E of n in master theorem, because there is an explanation for that one. I know based on the master theorem, E of n is like theta of n squared log n. That's what I found. I just go through every layer. I found this one is going to be equal to that one. What I'm going to do, I just put it there. I say, okay, this is going to be n log n. E of n is going to be theta of n squared log n plus n squared. So what's going to happen? How do you consider this one? I explain here. You see? Just consider what is the max. So I just look at this one. I say, okay, n squared, if I compare this n, multiple this one, is going to be n cubed. So I just ignore this one. So if I ignore this one, it's become n log n theta n squared log n. And this, if I consider this one, every time everything is going to be multiple this one. So it's going to be theta of what? N cubed log 2 of n. This is going to be the solution for theta. Does it make sense? That's the way how you calculate it. If you have any other example. Just want to make sure you guys understand this one, because this is going to be in an exam. Is it clear? Actually, you need to show, if you need to show this one holds. You know, this, you need to show how you find E of n. As I explained, you need to use master theorem to reach here. You need to use this one. It means you need to find this one first. And then put it there. And yeah, if you put it there. But you need to explain, for example, let's say, okay, n squared compared to this one, it can be ignored. I just said this one should be ignored, this part, and then I use this one and show. Yes. That's the way we need to prove it. Just want to make, because we didn't have any question like this in the past. I want to just make it clear that's the way we solve this kind of question. Just be really, really clear if you have it tomorrow. Does anybody have any question? If you don't have any Yeah, probably if you have any question, I would be happy to answer. If no, you guys can just, you can finish the class and you guys can start focusing on figuring, like reviewing all the document, all the notes and everything for tomorrow. So, and just be ready. Just as I explained earlier, this is open book homework, but it's not that you just need to just, without reading anything, do it. And then one more thing, I'm just really, I have, tomorrow you're gonna see the format of the exam. You see there is one question asked you guys that you sign, you don't copy paste from anything. Just wanna make sure I'm so clear. You're not gonna copy paste this question in ChatGPT and just do it. Because I'm gonna use algorithm to make sure. So just wanna make sure you don't do it. Just be really clear.
We can write down our answers, correct, and submit.
What?
It's okay. It's okay to write our answers and submit like a scanned version.
Yeah, you can write your scan version. Yeah. Just
Okay.
please. I just add some notes for some of the students when I was grading quiz 3. Please remove, if you take a screenshot of one big pages and then everything is empty, just only one part, just please remove the border. It makes it clear. So I don't need to just go zoom in and zoom out every time. Just makes it, if you use whole pages and you use only one part of that one. That's the first thing. And some of you guys use the pencils and it wasn't that clear. It was hard to read. It makes it, if it's too like every line like really compact and I cannot read it really well, grading is be hard. Maybe I'll miss some points. Probably need it, write it clean. Yeah, if you don't want to type it, I understand. Just use paper and pen, just submit it. And you have 15 minutes to do submission. Do you have any question? I grade everyone. If you send through email, I didn't grade the one through email. And what is your name? So let me check. Okay, just give me one moment. Let me check because I grade everyone. Probably didn't post. I found you. Let me see your grade. Oh, I see. Interesting. Okay. I think I just graded why I didn't put it here. Let me check it one moment. Okay, I will grade you after the class. It makes sense. Okay, got it. Anything else? Yeah, if you want to send me anything for the exam, please send it as soon as possible. Don't wait for the last minute. So